Hey, Reg audience, nice to see you again. We have a Regcast for you today on cloud native storage. You've got cloud native apps now. Do you need cloud native storage to go with it? Well, the argument we're going to make today is yes, you do. You're going to benefit a great deal from it. And we're going to show you why. And we're also going to be demoing today. And it's going to be live demoing. It's not going to be those fake demos that you see on other people's webinars. No, it's going to be a real live one. So there's going to be some tension. And, you know, who knows what will happen? Well, I'm sure it's going to go very well because today we introduce you to Alex Chircop from StorageOS. Hello, Alex. Welcome to our Regcast.
Hello, Tim. I'm really happy to be here.
Yes. And tell me, Alex, actually, while you're telling me about yourself, then we have a slide about you. And you're looking very good in the picture there on the slide.
Thank you. So my name's Alex Chircop. I'm one of the founders and the CEO of StorageOS, where we're building solutions for cloud native storage in these new cloud native environments. I have a fairly interesting background because before creating StorageOS and then going down the startup adventure, I used to work in infrastructure engineering for a number of large financial organizations, and so I have that experience of working with storage in the enterprise and kind of know some of those pain points.
You've done it. You have suffered like some of our audience have suffered. All of them have suffered. So yeah.
Indeed.
And you came out the other side and you thought, what I'm going to do is I'm going to set up StorageOS. When did you set up StorageOS?
So StorageOS was founded in 2015.
Mm-hmm.
And we got our first funding round in 2018, and that's when we launched the first version of our software. Since then, we've had over 5,000 clusters deployed, and today we're now in the process of growing out our enterprise customer base, where we're offering cloud native storage solutions for these enterprises who are adopting Kubernetes in production, whether they're running in the cloud or on-prem, or indeed, what's more common nowadays is some sort of hybrid or multi-cloud environment. Most of our clients today are in areas in sort of verticals that are maybe a little ahead of the curve in terms of Kubernetes adoption. So things like financial services and service providers and digital and SaaS companies, for example. But what we're finding is that Kubernetes is being adopted by developers everywhere and has kind of become the operating system for the cloud.
Yeah, because when you set up StorageOS, you must be thinking, all right, we're coming out of the financial crisis now. It's going to be pretty much plain sailing when it comes to the economy for the next decade or so. So it's a good time to set up, get some funding in, that sort of thing. Now, on the one hand, whilst clearly we've had a lot of economic pain, on the other hand, I guess that for some of your clients or future clients, this is accelerating the sorts of things that they're doing that you play into.
It is indeed. The pandemic has affected everyone, but from a technology point of view, there is a small silver lining in that. A lot of organizations are taking the opportunity to innovate and accelerate their moves to the cloud, and also to introduce technologies around being able to provide the cloud experience. I kind of have this sort of hypothesis that cloud is not specifically a place. It's enterprises want self-service, and they want on-off consumption models, and they want the automation around deployment and operations, and that's what they're trying to achieve with Kubernetes and containers and cloud environments.
Yeah. Well, we're going to look at exactly what you're doing. Meanwhile, for you guys that are watching this today, then we're very happy if you ask Alex some questions. tell us a little bit on what you think of what Alex is presenting and the points that he's making, you can do that by clicking on the little tab to, the little QA tab. Put your name in as well. It's so much nicer when we know what your name is, and we'll give you a shout out when we read out your question. If you want to do that, that is. But first of all, this is what we're going to be doing today. So we're going to be looking at why it is important to be cloud native when it comes to storage, how you get there, and how you get started effectively. And like I say, we're going to be finishing off with a bit of a live demo. And so, and there will be code in this presentation. If you want to critique Alex's code, then please go ahead. We welcome that kind of thing, that sort of open dialogue. Alex, I'm going to add this hand over to you now. So first of all, you've got to tell us why it's important that we're talking. Why are we talking about this?
Right. So I'll talk a little bit about why cloud native storage is important, and some of the challenges that this creates, and I guess some of the principles that we should be looking at to address some of those challenges. So I'll put it out there. The key reason why cloud native storage is important is because there is no such thing as a stateless architecture. All applications store state somewhere. Despite the kind of concept of containers being ephemeral and stateless, at the end of the day, the application that the containers are running will need to persist data somewhere. And in the cloud native storage world, that can be, a variety of different things. It can be, things like volumes and shared file systems. It can be services provided by cloud providers like, object stores, for example, or databases. But ultimately, you've made this investment in the cloud native world, and you need to consider where you're going to store the data, and you probably want to make sure that all of the advantages and all of the considerations that you've applied to your cloud native world also apply to the storage in the cloud native world.
Now, when your customers come to you, what's their thinking? Where are they in all of this? Have they come up against a roadblock where they're trying to do something that they can't? Are they unhappy with their performance? Are they wondering about how they're going to solve some technical problems? What makes them think of you?
Right. So I'll talk a little bit about the journey that we see a lot of our clients taking in a couple of minutes. But the key thing here is that they tend to come across key problems, because in cloud native environments and in Kubernetes environments, there are some challenges which tend not to translate well to some of the traditional storage environments and the non-cloud storage environments. So I'll quickly sort of highlight some of the most common challenges that our customers come across. So the first concept is this kind of this terminology of cattle versus pets, right? And it's amusing, but pets are kind of like these unique things that you care for, and that you and in the server world, these are the servers that you curate and you manage and are kind of unique and very beautiful and completely unreproducible. Whereas cattle are more homogeneous, and what we're looking to move towards in a cloud native world is this kind of concept where your environments are standardized, and the orchestrator, Kubernetes, can take what a developer needs out of the infrastructure environment and kind of make it happen, orchestrate that for the application. So we sort of refer to this as being declarative and composable. So what we're talking about is, a developer should be able to say to the orchestrator, hey, my application needs these containers to run, and it needs this type of compute, and it needs these network ports. But it also should be able to say, well, I need this type of storage, and it has to have these sorts of attributes. And that kind of leads me on to the second point, which is if you want your cloud native storage to be declarative and composable, then it has to be, API driven and have the hooks to have an orchestrator, dynamically provision storage, but also to move storage around. And more importantly, to have the dynamic capabilities to deal with the rate of change in these cloud native environments, because in a Kubernetes world, nodes come and go. The clusters are designed to scale up and scale down, etc.
Yes. Yeah.
The second challenge is actually specifically related to Kubernetes and containers, right? So when developers move to containers, they're effectively making their application portable, and when their application is portable, it makes it easy to orchestrate and to deploy anywhere in a cluster. Of course, the challenge here is that the data needs to be able to follow applications, but most traditional storage mechanisms present storage or volumes to a server rather than an application, which is kind of not that great, because if your application moves because, say, you've had a node failure, or because you're upgrading the cluster or things like that, then you want your data to be able to follow it transparently, and we call that application-centric storage. The second concept is again tied into Kubernetes and containers. Containers make it easy to run your application anywhere. You can pick up your application, run it on your laptop, run it in the cloud, run it on-prem, run it in VMware environments, etc. So you kind of want your storage to also have that portability and be platform agnostic, which is what is driving the general strategy and the general trends towards software-defined storage, as opposed to storage which is deployed in hardware appliances. And we talked about a little bit, I hate it every time I mention the word agile because it's just so terribly cliched, but the concept with Kubernetes is that it is meant to be dynamic. Clusters are meant to scale on demand, nodes can come and go, and it can react to workloads dynamically, and therefore you want your storage system to be able to react to all of those different changes and be agile in those environments.
You're bringing a whole bunch of concepts to the world of storage that aren't really what storage has been about for decades.
That's exactly right, and as we move to these new platforms, and as developers continue to adopt containers, and we have this tsunami, if you wish, of Kubernetes adoption across enterprises everywhere, we're kind of having to reevaluate some of the architectures and infrastructure patterns that we've been used to.
If we do not reevaluate, then what sort of situation are we going to be in? How much trouble are we in?
It translates into problems with scalability, problems with speed, but also it means that you often can't take advantage of some of the functionality that these Kubernetes environments offer you. So, if you want to be able to dynamically upgrade clusters or scale up clusters based on your web demands or your analytics workload, for example, but your storage can't move the data around and the storage can't fail over apps as quickly as you need them to, then you're not able to take advantage of a lot of the benefits in that new Kubernetes world.
Just before we move this one on, in the picture there, which animal's the application and which one's the storage?
So the picture is kind of meant to refer to the concept of data gravity. It's data is hard to move around, and providing that access to an app is the key thing. Hence, the little guinea pig leading the big dog.
Okay, I got it. In Switzerland, apparently it's illegal to buy one guinea pig because they're social animals. Just thought I'd put that out there.
That's fascinating.
It is, but probably another Regcast, isn't it?
Probably. So I'll just finalize the sort of the last challenge, which is in orchestrated environments and using Kubernetes, effectively you want to automate everything, and there are lots of good processes here, including GitOps, etc., which effectively give end users the ability to declare and compose their applications, just like we discussed previously. But the key thing here is it makes everything recreatable and reproducible. So, if you have the definition to start up your application and you have access to the data, then you can start it up anywhere and you can restart it anywhere. And you don't have this huge panic moment, if a server goes down that you have to worry about how you do restores and recover all those different dependencies, because everything is actually all defined. So in light of that, automating everything removes a huge number of errors in data centers, because let's face it, change is probably one of the single biggest causes of outages everywhere. Hence, why change management is so important in all of these enterprises. And therefore, in order to kind of continue that theme with the cloud native storage, you kind of also want some principles here where the storage is consistently available, can be performant, and offer that security to integrate with the policies in Kubernetes and encryption for cloud environments, etc. That you kind of expect out of those environments too.
There's a long shopping list here on what cloud native storage has to do, and any one of those things can be a deal breaker for in a situation, or cause some particular problems if you do not implement this well.
Definitely, and one of the big changes that we're seeing here, and this is something that we discuss regularly in forums and different communities, like in the CNCF, is that more and more the storage decisions are moving to developers from the more traditional infrastructure teams, and developers now have to understand the attributes, what storage attributes their application needs as they move to these new environments. So the developers need to have an understanding of their availability requirements and their consistency requirements and durability and performance, etc.
And that factors into how Kubernetes storage is going to work if you're going to implement it in a way that it improves the performance of the organization.
Exactly, because there's no point moving stateless applications into Kubernetes and kind of still have this ball and chain around your ankle where all of your legacy databases, for example, are sitting in your traditional environments.
Yeah. Okay, so explain to me, how does it work?
Right. So this is actually the typical journey that a lot of our clients kind of go through. They adopt containers like we just mentioned, and this gives them the ability for their containers to be portable and to break the dependency from individual servers, which obviously allows them to be automated and orchestrated with Kubernetes. But in much the same way, the developers need to be able to specify, compute and network requirements in Kubernetes. They also need to be able to specify their storage requirements, because all applications store state somewhere. So this is where software-defined cloud-native storage, like StorageOS, comes into play, because you kind of get the benefits of all of the world. You now have an entire stack which is declarative and composable, which means that then customers can move their applications, there's all of the stateful applications into Kubernetes. But more importantly, because all of this is self-service and it's all templatable, it allows them to build anything as a service. So we have customers building database as a service or CI/CD as a service, for example. And in fact, I'm going to show a little example how a few lines of YAML can start up a database on demand in a Kubernetes cluster in the demo a little later.
It's terrific. No one normally offers that, and and I'm very pleased that you are doing it.
I have made several offerings to the demo gods to hopefully make sure everything goes smoothly.
It's going to be great. I'm personally looking forward to it because I don't have to do anything. But seriously enough, it is really important to see how this stuff works in detail rather than just say, here was a bad thing, we got a good thing, and that's the difference. Yeah.
Right. So I'll talk a little bit about what this actually looks like in real life in Kubernetes.
Mm-hmm.
So in Kubernetes, we have the concept of a storage class, and a storage class. Think of it as an abstraction which connects Kubernetes to individual drivers for different storage systems. And you can create, different storage classes which refer to different types of storage, or indeed the same storage, but maybe different attributes of that storage. In much the same way that enterprises today might have a bronze, silver, gold plating for their storage rating. You can have slow, fast. You can have different business units defined as storage classes.
Mm-hmm. But you're creating those classes. It's abstracted from actually what the physical storage is.
That's correct.
Yeah.
And that storage class effectively refers to the drivers that Kubernetes would use to then talk to those APIs in the storage system.
Mm-hmm.
And today we have a standardized interface called CSI, which is the container storage interface, which is a standard API between the orchestrator Kubernetes and the different storage systems, which provides a lot of flexibility for Kubernetes users adopting cloud native storage. So here's what that storage class then enables. If a developer needs storage, so for example, they might need a 10 gig volume for their database, or their files, or a message queue or something like that, the developer would effectively make a persistent volume claim out of the storage class. And that persistent volume claim would create a persistent volume that now has a unique name that the developer can reference for their applications.
Mm-hmm.
And
what's in that claim? What does it consist of?
right, so the claim is really simple. It's just a name, and it defines the storage class that you're claiming against, and a bunch of attributes that refer to that storage class. So, in the most simplistic form, it would be something like the size, but it could also contain attributes like, the replication requirements, or encryption, or compression, or other storage services that the storage system might provide. Once that claim has been satisfied, effectively a persistent volume is now created, and that's dynamically provisioned. And then that claim can be referenced in the pod. The pod is a definition of your application, such that your pod can now consume that storage. And what's happening under the covers is that Kubernetes is actually mounting that volume. It's attaching the volume, mounting the volume. It's typically put a file system on there too, and you now have the application startup, and the volume is mounted into the namespace for that application. So the application sees that volume as just as if it's a local volume on a local server. And when the pod needs to move around, Kubernetes can reconnect it to the relevant volume. And this is kind of what it looks like. What I was describing sounds very complicated, but it's actually really simple. So a storage class is nothing but defining a name and which driver to use. So for example, in this case, we've created a storage class called fast, called StorageOS, and it refers to the StorageOS driver. The persistent volume claim, again, is a really simple thing. We're creating a persistent volume claim called database volume 1, and it needs to be 5 gig in size, for example. And then the application pod is saying, hey, I need to run up a Postgres container, and I want to have the persistent volume claim called data that we've created, sorry, the persistent volume claim called database volume 1 that we've created, mounted under /pg data. And now you have Postgres running with that volume and that file system in place. And that's literally all it takes to run a database in Kubernetes at a very, very, very simple level.
It is actually. Once you look at it like that, then you're thinking, oh, how complicated is this? It's more complicated than that.
It is, there is other stuff that's going on behind the scenes. Kubernetes, is automating things like service IPs and providing all of the HA capabilities and things like that as well, using stateful sets, which we'll talk about in a little while. But in principle, that's all you need to template creating a database. So if you wanted to create databases on demand, you can just have a little template to spin up a database every time you need to test something, for example, and then just delete it when you're done. And in fact, we have customers who do exactly this. They have CI/CD, large CI/CD environments that run, thousands of tests and effectively create and delete tens of thousands of volumes every single day. And this just happens on demand based on what the developers are coding.
And so, where does StorageOS fit into this?
Right. So StorageOS is a cloud-native storage platform. Obviously, we've been talking about some of the principles around having a storage platform that's application-centric and API-driven and composable and declarative, and that's what we've spent this time building. Effectively, StorageOS is actually deployed as a container within a Kubernetes environment. So effectively, we can be installed anywhere that runs containers, which nowadays means just about everywhere.
Yes.
And we will virtualize the storage that's available on individual nodes within a cluster. And that can be, physical disk on bare metal boxes. It can be virtual disk in VMs. It can be cloud disks in cloud instances. And we aggregate all of that storage and create a pool that spans all of the nodes in the cluster. And from there, we can dynamically provision volumes using, the concept of the storage classes and the persistent volume claims that we just described to provide highly available storage highly available and highly performant storage to the applications that are running within Kubernetes. And we kind of create this mesh and have the ability to provide a virtual volume and pop that up anywhere, so that as the app moves around within a cluster, it can continue to access the storage wherever that app is running. So hence, having that local sort of application-centric storage. Now,
how intricate can you get in what you're making available in this storage pool?
So it's, the platform has two components. We have the control plane that handles all of the integrations with Kubernetes and handles all the functionality to do robust placement, to handle locality or anti-affinity and things like that. But also we've created this concept of disaggregated consensus, and that's a bit of a mouthful, but fundamentally what it means is that every volume in StorageOS has its own mini brain, and that mini brain has the ability to make its own placement decisions and failover decisions, and that has two big benefits here, right? So the first is, we have extreme control plane speed. And this is really important because when you have a cluster with tens or hundreds or even thousands of pods and applications running, things move around a lot and things come and go a lot. So being able to do things quickly is important, and having the disaggregated consensus effectively removes any serialization points in that process. The second thing, though, which is really important, is it provides really strong reliability and durability, because even if there are transient network errors, or even if say the cluster is expanding or shrinking as you add or remove nodes dynamically, the volumes can make decisions independently, and volumes that aren't on the nodes that you're working on aren't affected by any of the other activity within the cluster. But we also have not just this automation, but all of the functionality in our data plane that provides the really powerful data services around synchronous replication to protect your data. The data plane has been optimized to provide market-leading performance, which is obviously really important, because low latency directly translates to transactions per second when it comes to databases or message buses, etc. And we provide security by providing encryption end-to-end of data and flight and at rest within the StorageOS platform. One thing I just want to finalize on is, we obviously are very focused on Kubernetes and focused on those environments, but we've also done a lot of work to make sure we're certified and integrated with some of the key Kubernetes distributions, like Red Hat OpenShift and Rancher, for example, and we're present in their catalogs and in the marketplaces. So in many cases, you can get a fully in just about every case, in fact, you can get a fully distributed, hyperconverged storage system with all of these enterprise functionality with a single command or a single click in any of these cloud environments, or OpenShift or Rancher environments.
And for anyone who's considering adoption of moving to cloud native storage, what's the process of adoption and migrating in this way? I suppose it's not too arduous, because you're not actually physically moving data around.
Well, you can do. It depends on whether,
I suppose, yes, depending on what you want to do.
In general, it can be relatively straightforward, and moving databases, message queues, file systems, etc. is relatively trivial and out of the box. The point that we have with StorageOS and Kubernetes, for example, is that you're and again, this is terribly cliche, but we're kind of democratizing enterprise storage for everyone, right? That was one of the foundation principles that I wanted to achieve with StorageOS all those years back, which was, if you wanted large enterprise class storage, in the past you had to spend 6 figures or 7 figures on these large big black boxes, but now effectively you can get that enterprise storage capability with all of the functionality that enables for your applications in a simple software package that you can deploy anywhere, whether it's really small or really large.
Okay, are we going to see how it works?
So in fact, I think the next stage that we wanted to do was actually run a little demo and actually show you what it looks like to run up a database in Kubernetes. So I am actually typing live. This is not recorded. Hopefully everything goes to plan.
Yes.
So one thing I'd like to sort of quickly mention, that if you have a Kubernetes cluster anywhere, you can get the StorageOS use cases, and all of these are documented on docs.storageos.com. So all of these, everything I'm running today are things you can do yourself, and you can follow the same examples in your own environments. I have aliased, just for simplicity, the K commands to kubectl, because I don't fancy typing all of those letters all the time. But what we have here is a simple Kubernetes cluster with 3 nodes. In this side of the window, on the right-hand side of the window, I'm running a little tool called K9S, which kind of just makes it a little easier to visualize what's running in the cluster. So this is what we've got running today. In sort of as system jobs, if you wish, we have the different StorageOS components which I installed earlier, and there are a variety of network components which come with this particular version of the cluster. But we'll hide that for the moment. What I'm going to show is the creation of a MySQL database, and I'm going to be using the MySQL examples in this use case. So this is what a stateful set looks like. So there's probably a little bit more detail here than we showed in the presentation.
Mm-hmm.
But effectively, what we're saying here is we're defining a stateful set with the name of MySQL, and within that stateful set, we are running up a MySQL container, and it's going to reference this volume claim, which is effectively saying, hey, create a 5 gig volume and give it that name, which MySQL will then reference. That's literally all there is to it. The stateful set has one other significant advantage in the Kubernetes world, which is it automates, it makes sure that there's always one pod of that application running at all times. So in this case, we're effectively creating a highly available MySQL database just by running the stateful set in Kubernetes. So I'm going to run that now. And what we see here is we see the MySQL database container creating, it's running,
Mm-hmm.
and that's all up and running. And we can see that the database is running on Node 2. So I will just show you on the command line what that looks like. So we have the MySQL pods running now, and I will also show you what we've done with the oops, there. That's proof I'm doing this live.
It is, and we needed that because otherwise it was just too good.
Indeed.
Yeah.
So effectively, this is the data volume that
Mm-hmm.
we just created. That's the claim and the claim name, and this is the actual persistent volume, which we see is now bound and mounted and is being used by the database. So what I will do is I will log on to the database.
Mm-hmm.
So this is a completely blank database instance. I will create a database called Regcast with Tim. And we see that database has been created. Okay, so I'm going to log out now. What I'm going to show now is how easy it is to do high availability now that you have the persistent storage with the MySQL database and StorageOS. So right now we've got MySQL running, and it's running on Node 2 with the persistent volume claim that we just created, and it contains this empty database called Regcast with Tim. What I'm going to do is I'm going to use a function in Kubernetes called cordon, which effectively tells Kubernetes to not place any new work on this particular node. So what I'm saying here is, hey, Kubernetes, don't put any more work on nodes 2. And what I will then do is, I will actually delete the running MySQL pod, and you'll see in the right-hand window, you'll see the MySQL pod die, and it should automatically start up on a different node. So this is the moment of truth.
Right.
There you
Yep.
go.
There we go.
It's terminating, and it's creating the node, and it's come up on node 3. And you saw that was an incredibly fast failover. The whole process maybe took 5 seconds tops. That was from terminating the database, with a kill effectively, and the database and Kubernetes automatically restarting it on another node. And just to make sure we're not cheating, we'll list the pods again. You see before it was on node 2.
Now it's on node 3.
Now it's on node 3. And just to make sure that the data is actually all present, I'll reconnect to the database, and we'll show the databases, and the Regcast with Tim database is still there. So that's a really simple example of, what we've done here is we've created a database. We've dynamically provisioned all the resources for this database, including dynamically provisioning the volume. We've created a volume that's highly available. We've created a database that's highly available, with Kubernetes doing its own health checks and making sure that the database is always running. We've killed a database, and Kubernetes just happily restarted it somewhere else and reconnected it to the data. And effectively, what you've got here is you've got the type of system that, maybe 10, 15 years ago, you would have had to spend literally hundreds of thousands of pounds or dollars to have a cluster with traditional storage to do this. And any developer can get this out of the box for free on their laptops now. This is game changing, because it means that developers can now focus on their code and what their application needs to do, as opposed to all the work that needs to go into making the infrastructure highly available and commoditized.
That is actually quite impressive. And, I was making fun earlier on and saying, it's fun to have a command line interface back on the Regcast after all this time. But genuinely, to see something like that happening live, well, good stuff. Thanks, Alex. That's that's really good. Now there'll be a lot of people who've seen that and said, I fancy some of that. I'd like to get going on that. How are our audience going to get going? Test this out, have a look, dip their toe in the water.
Right. So StorageOS is available for free in a forever free version for developers, which allows you to set up your first clusters up to 5 terabytes of capacity. The website provides all the information in terms of the platform overview, but also the documentation provides all of these examples and more for other databases and message buses and all sorts of platforms like Elasticsearch and Redis, for example. And you can also connect up. I strongly suggest that you take up the invitation to join our public Slack channel. We have our best engineers on there every day, and they'll be quite happy to talk you through examples or talk you through any queries you might have.
That forever free, is it? Are there any limitations on that?
There are some limitations in terms of the capacity size, like it's limited to 5 terabytes, but other than that, no, you can get full high availability in your environment, and then if you want some more advanced services, or you want to talk to StorageOS about deploying in larger clusters, or perhaps getting 24/7 support, our friendly sales rep will happily discuss that with you.
Yeah, but there's plenty of time that you could put into this, first of all, just to check it out, look, see how it's working, what you can do with it, that sort of thing.
Exactly.
You could do with that, and that seems to be a great way to get into it, have a go with it, and see what turns up. That's Alex, that's fantastic. Thank you very much. We're out of time now, But I got a feeling that this journey is just beginning for some people who've been watching it. So if you are even now clicking on that link and thinking, I'm going to have a go with this, let us know how you get on. Tell us tell us what you're doing, how well it works for you, because we'd be interested to know on this, and we'd be interested to sort of cover this sort of thing again, because I've got the feeling this isn't going to be the last that we hear of this topic. And so I might be presenting again on a Regcast about this. Who knows? We'll have Alex back as well, get him to do another demo.
I'd love to do that. Thank you so much,
you
Tim.
Say that now after you've done your, listen, Alex, no, that was really impressive. Thank you very much. Really do appreciate it. For all of you who've been watching today, really appreciate you tuning in on this. Hope it's been useful for you. As I say, let us know. But meanwhile, from all of us at the Register, from me, Tim Phillips, it's goodbye.